I wanted to quickly go back over reactions a little bit because I talked about it in the slide that mentioned enzymes. So the first self-replicating molecule was probably an RNA enzyme called a ribozyme. So again, I wanted to talk about enzymes, and in order to understand what an enzyme does, we need to understand activation energy. So activation energy is the energy needed to start a reaction. And we can see some examples here of reactions. So we have endothermic and, oops, did not mean to do that. Okay. We have endothermic and exothermic reactions. And so let's look at that word exo and endo. Exo means to exit, and endo means to enter. And so exothermic reactions lead to entropy, and endothermic reactions lead to order. And so let's see. Okay, so here's how I'll describe the two different reactions. If you look at a graph here, what you should do is just sort of erase this part with your brain. Erase the hump. And I want you to instead just look at the start and the end, the reactants and the products. This this y-axis is energy, and this x-axis is time or path. And so if your reactants start off with less energy and then gain it, you can see how the products are higher on the energy. Well, that means that energy was absorbed, and so this must be endothermic. Whereas here you can see it was lost, and therefore it is exothermic. So in this one, energy was gained, and so this created order. And in this one, it was lost, so this would be entropy. When a reaction leads to entropy, more directly, it is exothermic. Endothermic is when it leads to order. Okay, so the cool thing about enzymes is what they do in either of these reactions, whether it be this one or this one. Enzymes grab things. So if I were to draw, just because we didn't agree last time, if I were to draw an RNA molecule that folded in on itself, perhaps this is its shape. What an enzyme does is it grabs a substrate. So maybe this is the substrate and it grabs it. Sometimes it carries it somewhere to drop it. Sometimes it'll just change its shape. So if it came out, maybe it would be a different shape. Sometimes it, I'm trying to think what else. Sometimes it smushes two things together. So maybe it will smush two of these together, meaning polymerize. So in either case, what an enzyme will do for such a reaction is it will reduce the activation energy. So instead of looking like this with this big hump, this graph would look like this. That is less activation energy. Or maybe it would look like this. In either case, that's less of a hump. The bigger the hump to get over, the more energy you need for the reaction to occur. And so that is what an enzyme does. It reduces activation energy. Just wanted to remind you where you were looking at from biology.